Hi everybody, welcome to the channel Mooniverse. So this is the part 2 video of CPU scheduling algorithms. In this video, we are just going to see what is preemptive and non-preemptive CPU scheduling algorithms. That is, uh, in the CPU scheduling algorithms, a few algorithms can be preemptive and also non-preemptive. So first we have to understand what is non-preemptive and what is preemptive. So let us see in this video. So before getting into that, we can just see what all the categories of CPU scheduling algorithm. So um, as you see here, there is something called as first come first serve, then shortest job first, then shortest remaining job first, then priority scheduling, round robin method. So these are all basically the common algorithms what we used to learn, and the others are longest remaining job first, longest job first, and highest response ratio next. So likewise, so these algorithms will be categorized under preemptive and non-preemptive algorithm. uh, by making a small change in shortest job first, this by making it as a preemptive algorithm, it can be considered as the shortest remaining job first algorithm. So likewise, we are going to see. So before getting into the algorithms, it's better to learn the difference between the preemptive and non-preemptive algorithm, right? So now let us see the illustration of non-preemptive scheduling. So at time 0, process 3 enters the ready queue with burst time 2. So as the CPU is idle, the process P3 enters, starting its execution from time 1. So when it is being executed, another process P4 enters the ready queue. So with a burst time of 4. As it is a non-preemptive scheduling, the process which had recently joined the ready queue has not been considered, and P3 is going on executing, right? Now at time 2, P2 enters the ready queue, as there is a burst time of P3 is 2, and during the time T, it has already completed 2 units of time in the processor. The execution is completed and it readily e- exits the processor. So now again the processor become idle. So now P4, which is next in the ready queue, enters the processor. So it is having an execution time of 4. So for 4 unit of time, this P4 will be executed, in which the at third unit of time, P1 enters into the ready queue. So as it is a non-preemptive, it is continuously being executed without any interruption of the processes inside the ready queue. Again, after the burst time of 4 units, P4 has to exit the processor. So now it is exiting the processor, and the next process, which is P2 inside the ready queue, enters into the processor. So in the previous slides, we saw what is non-preemptive. To get a better understanding, we should also know what is preemptive scheduling. So preemptive is while a process is being running in the processor, another process will be coming inside the ready queue. Comparatively, the second process which is entering will be having higher priority, or it will be having some emergency that it has to run immediately. So in such cases, the current process which is running in the processor will be stopped, and it will be removed from the processor, so that it is making space for the new process which is having an emergency to get into the processor, will be entering into the processor to run for execution. So here, while we are considering the preemptive, I'm just going to uh, say about the priority scheduling algorithm. So another one factor here, priority is considered. So let us see the example for a better understanding. Now process P1 enters at time 0 and it is having the priority 3 and its burst time is 5. Okay. Next, so as the processor is being idle, this P1 directly enters into the processor as there is no competition for P1. Now, after its execution for 2 unit of time, now enters the process P2, which is having a higher priority when it is being compared with P1. So among 1 and 3, this P2 is having the higher priority. So now it is time to take away process P1 from the processor to the ready queue. It will be put back to the ready queue, right? And P2 with higher priority enters the processor for running. And the burst time of P2 is 3 units of time. So let us see what's happening. So the P2 is running for the first unit, and during its running, P3 enters the scene, and P3 is having lesser priority. So when we are comparing this P3 and P2, P2 is having, that's why P2 is being executed again, and the burst time has been completed for P2. So now it's time for P2 to leave the processor. So it is leaving the processor. Now here in the ready queue, there are two processes, P3 and P1. So now we have to check the priority. So coming to the priority check, this P3 is having higher priority. Okay, higher priority than P1. So now P3 will be entering the processor. Already P1 is waiting for a long time, even though as it is a preemptive scheduling, P3 will be entering the processor for execution. So it will be executed for its burst time of 2 unit of time, and then after completion of that one, it will be getting out of the processor. Now only one process is left over, that is P1, and its burst time is 5 units, and already it has completed 2 units of execution. So remaining, that is 5 minus 2, the remaining is 3 units. So now it will be executed for the next 3 unit of time, right? So this is preemptive scheduling. Hope you should have understood what is preemptive. In the last non-preemptive scheduling, what happened was, while the process enter into the processor, it is not disturbed by the newly coming process which is getting inside the ready queue. But here, some factor which is called as priority, it is affecting the currently running process. It is being stopped, and in case if it is needed, it is removed from the processor, and the process which is in an emergency to enter into the processor will be getting into the processor, right? So this is one thing. This is called priority scheduling, and this is one of the example of preemptive scheduling. So this slide is having the differentiation between preemptive scheduling and non-preemptive scheduling. So initially to say, we have to say when the CPU will be terminating the process. So in the non-preemptive scheduling, the process which has entered the CPU will be holding it until it is terminated. Terminated is until it completes the burst time, we can say. Okay. So we'll be shortly calling it as BT. But in preemptive, process may or may not be terminated depending upon the new process which is entering into the queue. It can be a shortest, it is having a shortest burst time compared to the process which is running currently in the processor, or it may have a priority um, than the process which is currently running in the processor. So obviously, when uh, we are considering the second point, when the process enters the processor, it will be holding the processor until its burst time is completed, means no other process can interrupt it, right? So the second point is the thing, no other process can interrupt it. Okay. So here, obviously, other process which are having higher priority or which are having shortest job or considering the priority, the process running in the processor can be interrupted. Interrupted means it will be stopped from the execution and it will be brought back to the ready queue, right? So here, coming to the third point, a new process uh, is allocated to the CPU until it's completely executing, running the task. And here, the new process can be allocated in the midst of the execution. So the processor will not stop during the non-preemptive scheduling until it finishes the process which is currently being executed. Here it's not like that. Okay. Hope you have understood the differentiation. Thank you. Thank you for watching. Hope you have understood the difference between preemptive and non-preemptive. As a short, I'm saying that a processor is having a process running on it. When another process enters into the ready queue and it is having some emergency to enter into the processor immediately, if it is being interrupted, it is called as preemptive. If the coming process is not interrupting or it cannot interrupt even though if it is having any requirement or any emergency need, it is not able to interrupt the processor means it is non-preemptive. Okay. Thank you. Thanks for watching.